Now in this problem, we are asked to graph the rational function. What's nice is they've given us the original function f of x. So from that function, we should be able to find the y-intercept, plugging in 0 for x, we get 0, -3 over 2. For our x-intercept, when we plug in 0 for y, we get 3, 0. We also see that the ratio of our leading coefficients gives us our horizontal asymptote, which is y equals -2, and our vertical asymptote when our denominator equals 0 is that x equals 4. So we can only find this if we have our original function, which we do in this case. Now, in order to determine where it's increasing or decreasing, we need our first derivative. So this is going to be quotient rule, high, this is low. So it's low d high minus high d low, square the bottom. So simplifying my numerator, I have 8 minus 2x, and then that's going to be plus 2x minus 6, all over 4 minus x squared, and now the 2x's cancel. So our derivative is 2 over 4 minus x squared. So notice that some problems might start with giving you only the derivative. And once you have your derivative, you can get an idea of what's happening with your original function. So I see f prime of x does not exist when x equals 4, and that's because there is a vertical asymptote. But we can still use that critical value to see what is happening with our original function. So actually that's just f. So if I pick a number less than 4, we get a positive number, which means my function is increasing. And if we pick a number greater than 4, it's also positive, so my function is increasing around that vertical asymptote. So now I'm going to find the second derivative so that I can evaluate where it's concave up or concave down. So f prime of x I'm going to write as 2 times 4 minus x to the -2 power. So I can take the derivative using power rule. So I'll have -4, 4 minus x to the -3, chain rule multiplied by -1. So my second derivative is positive 4 over 4 minus x cubed. And once again, this does not exist at x equals 4. So now I can use another sign chart here with 4 as my crucial point, and we are comparing our second derivative to our original graph. So if we pick a number less than 4 and plug it into our second derivative, we get a positive number, so our function's concave up, and a number greater than 4 gives us a negative second derivative, which means it's concave down. So remember, this is not an inflection point because f of 4 does not exist. It's a vertical asymptote. So now we can take all of this information and sketch our graph in the next video.